The weekly contest 295. This is the first problem. The difficulty is C. Problem 2287. So please click the like button to help support this channel. While for now, let's start reading about the problem itself. Rearrange characters to make target string. Basically, we have two string S and target, and the question is from the letter S. From the letters of the string in S, how many copies of target that we can create. An example, and we have to return the maximum number of copies of target that we can form by taking the letters from S and rearranging them. It means that out of these letters, we are asked how many can we create this target string. It means once you take the letters to build one version of the target, you cannot reuse it. For example, in this string, the answer is 2. The first copy of the target string code taking the letter from 5, 4, 5, 6, 7, which is 0, 1, 2, 3, 4, E, 5, 6, 7. You see, you can take the letter without the right order already. But the answer is only 2. If you notice, the second copy is taken from a totally different set of indices, right? So that's basically what the problem is about. In my case, my personal case, that was the tricky part about this problem, actually, to understand it correctly, that it's not about a combination you can make out of it, but it's about like you are taking from a set. Once you take that to be used to create a target, you cannot use it anymore. That's why the answer for this is 2. So how can we solve this, right? How do we get these numbers? In order, one way to get these numbers, now we are talking about the tactic, okay? To get the answer to this, one of the way is to convert this into a map of the character or letters to frequency. So let's take this one. So the strategy is to understand what can we take and how many is the maximum we can create out of it, is actually to convert this into a map. The first conversions that we have to create, of course, the target itself. So target code, we can create it into C. We need one C, we need one O, we need one D, and we need one E. That's the equivalent letters to frequency map. Now, after we have that, we have to do the same thing for each corresponding letter that is existence in the target, but we do the frequency mapping from the S. So for character C, for example, here we will have 1, 2, frequency of 2. For character O, we have 1, 2, 3, 4. For character D, we will have 1, 2. For character E, 1, 2, 3, 4. Now, after we got the frequency of the required characters that actually exist in the target, the next thing we need to do is first we need to check whether all the letters needed are there. Okay, if it is there, if it is not, for example, if there isn't any E, it means we quickly know that it's not possible to build the string target, the code here, out of the S. So that's the first requirement. The second one is actually after we got all the counter, we have to convert it by dividing it with the frequency from the target. Because, for example, everything has to be a multiple of the target. Otherwise, we couldn't build it, right? For example, an antithesis, if we have only, maybe this one is a little bit because everything is only one. But let's say we need 2E. So rather than code, it will be code D, for example. Then, if we only have one E here, if we only have one E in the S, this couldn't create this one because this one for one target word, it requires at least 2E, right? So, if there is less than what we need for any of this, then the answer also 0. Then how do we know it? Maybe let's make it into one first. Later we'll try the problem with code D instead of code, okay? But for now, let's keep on the examples first to understand the concept. So now continue back to what we left before, that how many can be created is based on the divisions, and it has to be an integer of it because you cannot create something out of a comma. So for example, we need one C for creating a target. Here we have 2. So based on the C information itself, we know we can create at most 2, right? So that's the potential we now have. We potentially can create 2. That's when we check the character C. Now goes to the character O. From O we have 4 in S. We need only 1 to create the target. So in such case, we have actually a potential of creating 4 target if we only look at the O. But previously we know we got from C we have the potential 2. Of course, we need the C. And the one that is possible is of course the minimum. We don't have 4C. Therefore, although we have 4 O's, it doesn't mean we can create 4 targets because we already know from the limitation we met during comparing the C that we can at most create 2. So it becomes a logical comparison of what was minimum. In this case, although O is 4, we can only create 2. Then D is 2, we only need 1 D. So from D the potential is also 2. Then we still cap the potential into 2. For E, we need 1. So this is the case. And then 2 compared to 4, the minimum will be still 2. So 2 is the maximum that we can create out of the S. We can create maximum 2 targets out of the letters we have in S. Okay? So now let's take the examples into the edge cases where I'm mentioning about. If let's say we need actually 3E. Okay, so it's become code D. Of course, this profile still kept the same because we don't change anything about the S. We only change the target by adding 2 E character. That's why the E frequency required become 3. Now, if we cap on the divisions, this become this. Okay. So 4 per 3, of course, the integer division solver of it is only 1. It's 1 point something. You cannot create something out of a point, right? In order to create a complete word. That's why we took on the floor integer of it, 1. So out of this, we can see that the minimum now change become 1. Minimum of 2, 4, 2, and 1. This become 1. It means once we change the target into this, become code D, now the answer change into 1 because we have insufficient number of E to create more than 1. We only have 4 E inside S. It means at maximum we can only create the word Cody only 1. So that's the tactic. Now in summary, the tactic will be convert the target first into a letter to frequency mapping, then generate the letter to frequency mapping in S for only the letters that is inside the target. Okay, and then thirdly, we divide all the letters exist from what was inside the target to see how many multiples for each of the character we can create. And the answer to the maximum target we can create out of S is the minimum of the resulting division. And this was another example to show the edge cases, because this one was the division are all just nice. This one is the edge cases when the division is not that nice. Okay, so that's the steps. Now about the code, I have a prepared code already, which I used to submit during the contest itself. So this is the first step, which was about generating the letters to frequency map for the target. Okay, so the idea is simple, looping through the characters. If the characters not yet in our map, we initialize this. Other than that, we increase the frequency by 1. By the end of this step, we will have the letter to frequency map. Okay, then the next step is about the letter of target inside the S. That's why I call this ST target count map. The idea is the same. We explore all the characters in the S, and then if the character is also in the target count map, only by then we do something similar with here. Whereas if it is not yet in our ST count map, we initialize it. Otherwise, we increase the frequency by 1. So by the end of line number 39, we will have this. Okay, then finally is the section where we do the division. So based on the target count map, this is what we do. If ever we find a character in the target count map that is not in the ST count map, it means we early return 0. Because we know that we couldn't create the target string at all. The character is not exist at all in the S. Otherwise, we will count. We will take the counter from the ST count map. And if ever we also find where the S count is less than the target count, it means we don't have enough letters to create the target. So although the letter exists, there is just not enough frequency. Therefore, we early return. Notice that this is return, right? Early return. This is not like intermediate counting, but this is directly returning, declaring that it's not possible. And otherwise, what happened is we do the division just now. This is the way in to do integer division. So you will get integer out of this division if you do this double forward slash in Python. So that's how we do it. And what happened is, if we never before have any total, of course we initialize it. If we already have it, we will do a minimum comparison. Remember what we did here? Minimum. So that's what this is actually doing. So we do a minimum comparison between the previous total we have with the new potentials. Okay. Finally, we return the result. Let's see whether this is accepted when we submit this. And it is accepted. Okay. So that's basically it about the code implementation itself. Now let's do the final part of this, which is about the time complexity. Okay, this is a looping of each character in the target. So let's say the length of the target is M. So this is big O M. Everything here is just a check into the hash map and then do initialization and increment. So this is big O M for this section. How about this section? This is looping through in the S, and then for each S, it will later on checking in the first map, second map, and then do initialization or increment. So all in all, this is big O n, where n is the length of the number of characters in S. Right, while this one, this is looping through the target, so this is another big O m. And this is just a check, and then just another check, comparison, and division. So in the end, this is big O m. Now, as this is sequential, we do a plus of this. In the end, it becomes big O, either max M or N. Most of the case, I suppose for this problem, it will be the N that is actually larger than the M. So we can say that this is a big O n time complexity. So that's it for the first problem of this weekly contest. Thank you for listening in. Please click the like and subscribe the channel if you like it.